Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything on your upcoming test. So it covers equations and inequalities and related word problems. So let's start with equations. An equation is something like this that just has an equal sign. We want to solve equations. That is, we want to find a value we can substitute for the pronumeral that makes the equation true. So how exactly do we go about doing that? Well, what you do is you undo everything that has been done to x, or whatever the pronumeral is, in the opposite order to BIDMAS. What do I mean by that? So in this equation here, x, the pronumeral, has been multiplied by -4 and 19 has been added. We did things in that order because of BIDMAS. We multiply before we add. So when we're solving, we need to do things in the opposite order. It's like you put your socks on first in the morning, then your shoes, but then when you take them off, you have to take off your shoes first because they were the last thing you put on. So here 19 is like the last thing I put on. So it's the first thing I get rid of. So I'm going to get rid of the positive 19 by subtracting 19 from both sides. What you do to one side of the equation, you must do to the other. So 19 minus 19, they just cancel out, and I'm left with -4x equals 33 minus 19, which is 14. So now I'm going to undo timesing by -4 by dividing each side by -4. So 14 divided by -4 is -3.5. So don't feel that you've done something wrong merely because your answer isn't a whole number. Answers are not always whole numbers. So this is the solution, because if I substitute it here for x, I get 19 minus 4 times -3.5. And you can check your calculator, that does equal 33. If I substitute x for -3.5 into here, I get a true statement. All right, let's look at this equation here. So here we've taken our pronumeral x, we've subtracted 5, then multiplied by 2, and then divided by 3. So because dividing 3 is the last thing I did, it's the first thing I undo. So you undo dividing by 3 by timesing by 3, because they cancel each other out. Once again, what you do to one side of the equation, you must do to the other. So I'm left with 2 outside of x minus 5 equals 16 times 3, which is 48. So now I can divide by 2 or expand the brackets, either's fine. I'm going to expand the brackets. So I go 2 times x is 2x, 2 times -5 is -10. So now to solve this equation, I know because of BIDMAS, I multiplied by 2 first, then subtracted 10. This is the last thing I did, so it's the first thing I undo. So I'm going to undo subtracting 10 by adding 10 to each side. Because minus 10 plus 10 undo each other, I'm left with 2x equals 58, and now I'm going to undo multiplying by 2 by dividing by 2. Once again, what you do to one side of the equation, you must do to the other. So my solution here is x equals 58 divided 2, which is 29. This is the solution because if I substitute x for 29, I get 2 times 24, 48, divided by 3 equals 16. That's a true statement. All right, let's now look at some equations where the pronumeral is on both sides of the equal sign. So in order to solve such equations, we just need to do a couple of extra steps. You need to get rid of any fractions or brackets first, then you subtract the pronumeral with the lowest coefficient. We do this because each of these equations has x, or the pronumeral, in more than one spot. We really only know how to solve equations where x is in one spot. So after you've done these two steps, you can just solve as normal. Let's look at this question here. So we can see x pronumeral is on the left and right hand side of the equal sign. So there are no fractions or brackets to get rid of, so I'm going to subtract the pronumeral with the lowest coefficient, i.e. lowest number in front of. So that's this one here. So what I'm going to do is subtract 7x from this side because it will get rid of x from the right hand side of the equation. But of course, what I do to one side of the equation, I must also do to the other. So on the left hand side of 8x minus 7x is just x. Remember, you can't subtract 7x from -3. They are not like terms. The -3 just stays as it is because it has no like terms. And then similarly, the 2 I can't subtract 7x from 2, it just stays as it is. So now this is a really easy one to solve. X minus 3 equals 2. We're just going to add 3 to both sides of the equation. We end up with x equals 5. All right, let's look at this equation here. Once again, we have pronumeral on both sides of the equation, and we don't have any fractions or brackets to get rid of. So I'm going to go straight to step 2 and subtract the pronumeral with the lowest coefficient. So this x here actually has a coefficient of 1. X and 1x are the same thing. The coefficient of this x is not 5, it's actually negative 5. So what I'm going to do is I'm going to subtract negative 5x from both sides, because negative 5 is obviously less than 1. But remember, subtracting a negative just is the same as adding. So what I'm going to do is add 5x to the left-hand side, then I will only have a 7 on the left-hand side. If I add 5x to the right-hand side, x plus 5x is just 6x, and then I leave the 1 alone. You can't add 1 and 5x, they're not like terms. So this is an easy solve again. Subtract 1 from both sides, and then divide by 6. And I get x equals 1. All right, let's look at this one here. So here I do have some fractions as well as the pronumeral on both sides of the equation. So first step, I'm going to get rid of the fractions. So to get rid of this fraction, I need to multiply by 3. So when I multiply this side of the equation by 3, of course, divide 3 times 3, just cancel each other out. When I multiply this fraction by 3, when you multiply a fraction by a whole number, only multiply the top. I don't multiply the 4 by 3 as well. That doesn't work. You can't multiply top and bottom by 3 because that's the same as multiplying by 1. So when you're multiplying a fraction by a whole number, only multiply the top. So similarly, I'm going to get rid of this divide 4 fraction by timesing by 4, because divide 4 times 4 undo each other. So I need to also multiply this side of the equation by 4 in order to keep it balanced. So note that when I'm multiplying this side of the equation by 4, I need to multiply the whole thing by 4. So now I've got rid of the fractions, but I still have some brackets. So I'm going to get rid of the brackets by expanding each side. So 4 times x, 4 times negative 2. Then we have negative 3 times 4, negative 3 times negative x. Negative times a negative is always a positive. So now I've done the first step, I've got rid of any fractions or brackets. I need to subtract the x with the lowest coefficient, which is that one there. So if I subtract 3x from this side, of course 4x minus 3x is just x. I can't subtract 3x from negative 8 because they're not like terms. So now what I do is add 8 to both sides of the equation. I get x equals minus 4. That is my solution. All right, let's now look at inequalities. So inequalities are very similar to equations, except instead of an equal sign, we have a greater than or less than sign. So you solve inequalities the same way as you solve equations. So we're going to undo what's been done to the variable in the opposite order to bin mass, except if you need to multiply or divide each side by a negative number, you need to reverse the inequality. So I'll show you what that means in the second example. But for the first example, we're just going to solve it like an equation. So what we're going to do is first multiply each side by 3. So when I multiply this fraction by 3, remember that times 3 and divide 3 cancel out. So I'm left with x minus 4 is greater than 6. So now I'm going to add 4 to both sides. I get x is greater than 10. So there are infinitely many solutions to this equation. 11 is a solution, 12 is a solution, 13 is a solution, and so on. We're going to graph these solutions on the number line. So we number our number line, so 10 is in the center. So we want to include all numbers that are greater than 10. So what we do is we draw an arrow from 10 to indicate all of these numbers are solutions. Now we put a circle at the end of the arrow. So because we're not including 10, the circle is open or not shaded. So this is the graph of x is greater than 10. Now let's look at this inequality here. So what we need to do is first subtract 7 from both sides. So I get negative 2x is greater than or equal to negative 6. So this is negative 2 times x. To get x by itself, I'm going to need to divide this side by negative 2. What you do to one side, you must do to the other. When you're dividing or multiplying each side by a negative, you need to reverse the inequality. So negative 2x divided negative 2 is just x. Negative 6 divided negative 2, well, that's just 3. But what I need to do is reverse the direction of this inequality. So this is a greater than or equal to. I'm going to switch it so it's a less than or equal to. You only do that switching, reversing the inequality, when you are multiplying or dividing each side by a negative. So the solution here is actually x is less than or equal to 3. So put 3 in the middle of the number line. I'll number a few numbers either side. So we draw an arrow from 3, pointing to all the solutions we want. This time we want all the numbers that are less than 3. Now here we're including 3 in our solution because this is a less than or equal to. So this time we shade in the circle. So you always have a circle at the end of an arrow. If it's greater than or less than, circle's not shaded. If it includes that value, so less than or equal to or greater than or equal to, you shade the circle. All right, let's look at this inequality here, sometimes called a nested inequality, because there's kind of two inequalities. Negative 5 is less than or equal to 2x plus 1. That's one inequality, and 2x plus 1 is less than or equal to 5. We can solve each of these separately. So solving this first inequality, we're going to subtract 1 from both sides and then divide each side by 2. So I get negative 3 is less than or equal to x, which means x is greater than or equal to negative 3. So solving the second inequality, exactly the same steps. Subtract 1 from both sides, divide each side by 2. So what we found by solving each of these inequalities is that in order for this statement to be true, x has to be greater than or equal to negative 3, but less than or equal to 2. In other words, it has to be between and including negative 3 and 2. So let's show this on a number line. So note that I'm including each value negative 3 and 2 in my solution. So I'm going to draw shaded circles at negative 3 and 2. So all I want is any number between them. So I just draw a line like this. Now this line, of course, doesn't have an arrow because it doesn't go forever. I don't want numbers over here as part of my set of solutions. I don't want numbers over here. So we're actually done. All right, let's now look at some worded problems. So whether the worded problem involves equations or inequalities, always follow these 3 steps for worded problems. Define the variable, which means let x equal whatever the question's asking you to find, then form an equation or inequality, then solve it just as we did on previous slides. I'll go through what this red bit means in the next example. So for this example, James sells tyres. He earns $20 per hour plus $8 for each tyre that he sells. How many tyres must he sell in an 8-hour shift to earn at least $300? So we start by letting x equal what we're trying to find. This question asks us to find how many tyres he must sell. So I'm going to let x equal the number of tyres that he must sell. So that's step 1 done. Step 2, let's form an equation or an inequality. So the amount of money he earns in total, he earns for 8 hours $20 per hour. He also earns $8 for each tie that he sells. So this is an expression representing the total amount of money that he earns. We want that to be at least 300. At least means greater than or equal to. So now we're just going to solve this inequality. Of course, 8 times 20 is 160. He earns $160 even if he sells no tyres. So solving this inequality, we're going to subtract 160 from both sides. So we get 140. That basically means he needs to sell enough tyres to earn $140. So dividing each side by 8, we actually get 17.5. So he needs to sell at least 17.5 tyres. Obviously, he can't sell 17.5. the number he sells has to be a whole number. So we're going to end it by saying he needs to sell at least 18 tyres. So note, if he sells 17 tyres, he will earn just a little less than $300. If he sells 18 tyres, he will earn a little more than $300. All right, let's now look at a harder worded problem. So here we're told Agnes is the grandmother of Angus. Agnes is 58 years older than Angus. In 11 years' time, she'll be triple Angus's age. How old is each person now? So this question's a little harder, apart from the difficult words, because there are two quantities that you need to find. You need to find how old Agnes is, the grandma, and the grandson Angus, how old he is. So this is what this red bit here means. If there are multiple unknown quantities to find each variable in terms of the same pronumeral, what the heck does that mean? Well, what it means is we're going to start by letting x equal one of the things you're trying to find. Doesn't really matter which one. So let's let x equal the age of Agnes, the grandma. So what we need to do is we need to write Angus's age in terms of Agnes's age. We need to write Angus's age using an x. We can't introduce another pronumeral. We don't know how to solve equations with two pronumerals. So if Agnes is x and she's 58 years older than Angus, Angus's age is just whatever Agnes's is minus 58. So notice we've used the same pronumeral, same letter for each of the unknown quantities. It's important we do that. Can't let x be Agnes and y be Angus because we don't know how to solve equations that have two pronumerals. So now we're going to rewrite this worded information in a mathematical equation. So in 11 years' time, Agnes will be whatever her age is now plus 11. So we're told that that will be triple Angus's age in 11 years. Well, if Angus is x minus 58 now, in 11 years, he's going to be x minus 58 plus 11. You just add 11 to his current age, and you have his age in 11 years. So x minus 58 plus 11 is actually x minus 47. So now we have an equation to solve with pronumerals on both sides. So remember the rule is we first get rid of any brackets. So we go 3 times x is 3x, 3 times negative 47 is negative 141. So now what we're going to do is subtract x from both sides. This is the pronumeral with the lowest coefficient. Its coefficient's 1, 1 is less than 3, so subtracting x from both sides leaves us with 11 equals 2x minus 141. So now we're going to add 141 to both sides. We get 152 equals 2x. Dividing each side by 2, we get x equals 76. So what is that number? Well, we said x was Agnes's age. So that means Agnes must be 76, Angus must be 76 minus 58, which is 18. Because that makes sense. In 11 years, Angus will be 29, Agnes will be 87. 87 is triple 29. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.